Hello, greetings to everyone. I'm Hanabila Jomis. This project is presented by our group, which consists of myself, Agnesia, and Felicity from AS120 Part 2. And we are focusing on reinventing the steering systems using concepts from rotational mechanics and thermal physics. Steering systems are essential in vehicles for maintaining direction, control, and safety. Traditional systems, especially in older or manually operated vehicles, often require significant rotational force, leading to driver fatigue, especially during traffic or long-distance travel. Additionally, in hot climates like Malaysia, steering wheels can absorb heat, making them uncomfortable or even painful to touch. These issues inspired us to develop an innovative steering system that not only reduces physical effort but also addresses thermal discomfort. Our aim is to apply the principles of rotational mechanics to enhance steering efficiency and precision, while using thermal physics to regulate temperature through heat-dissipating materials or internal cooling systems. Through this project, we hope to improve everyday driving comfort and safety, especially for frequent drivers and those in hot environments. We believe science and physics can offer real solutions to real-world problems. Now, we move to the next section. Our project is based on two important physics concepts, rotational mechanics and thermal physics. From rotational mechanics, we use concepts like torque, moment of inertia, and angular motion. This helps us understand how the steering wheel turns and how to reduce the effort needed during rotation. From thermal physics, we apply ideas such as heat transfer and conduction. This is important because in hot environments like Malaysia, the steering wheel can absorb heat, making it uncomfortable or even painful to touch. These theories support the improvements we design in our steering systems. Now, let's talk about the working principle of our innovation. Our improved steering system works in two main ways. First, we reduce the physical effort needed to turn the wheel. This is done by using mechanical aids, such as improved gear system or gyroscopic balance based on rotational mechanics. Second, we solve the overheating problem by using thermal regulating materials or cooling channels in the steering wheel. This helps keep the wheel cool and comfortable to touch using the concept of heat conduction. With this design, our steering system becomes more comfortable, efficient, and safe for the driver, especially during long drives or in hot weather.
What is the key need? The key need is to improve the control and efficiency of vehicle steering. This is especially important during shutdown, high-speed driving, or tight parking situation. Why? Because steering system rely on rotational motion, the turning of the steering wheel, the gear system inside, and how that motion is transferred to the tire. If that system isn't smooth or responsive, the whole driving experience become more dangerous and tiring. Whose need are we talking about? Primarily, this need affects two main groups. First, driver of compact and electric vehicles like the Perodua Asia or Tesla Model 3. This car often have lightweight steering system which can feel either too loose or too stiff depending on the road condition. Second one is car manufacturers who are constantly under pressure to design safer, more energy efficient, and more responsive steering system, especially as the demand for electric vehicles grows. How often does this happen? This happens very frequently. Driver experience poor steering feedback almost every day. During sharp U-turn, narrow parking spaces, or at highway speed, where even a slight steering delay can be dangerous. This issue is even more obvious in cars that use a fixed gear ratio for their steering, which means the turning response doesn't adapt to the speed or situation. How big is the problem? Honestly, it's bigger than we think. Poor steering control can lead to higher accident risk, especially in emergency situations. It also increased driver fatigue because drivers have to overcorrect or use more force to steer. And also more wear and tear on steering component, which mean higher maintenance costs over time. When rotational mechanics are poorly optimized in a vehicle steering system, both safety and efficiency are compromised. What happens if this need isn't met? If we don't address this problem, several consequences follow. For example, driver will continue to have less control over their car. The risk of accident increases, especially for new or elderly driver. And over time, the vehicle mechanical part wear out faster, leading to expensive repair and shorter vehicle lifespan.
Hi everyone, I'm Felicity and today I want to talk about something we often don't think much about, which is steering systems in vehicles. Even though it seems simple, but poor steering can cause accidents, make drivers tired and damage the car over time. So, how can we make steering smarter, safer and easier? That's where our idea comes in. First, let me explain our approach. We focus on using smart technology and basic physics to improve how steering works. We want the system to be more responsive, easy to control, and more efficient. Here's how we do it. First, variable gear steering, which change how sensitive the steering is depending on the speed. Second, electric power steering. It's to reduce the effort needed to turn the wheels. Last, smart adaptive steerings, which adjusts automatically based on road and driving conditions. This approach doesn't just add comfort, it also improves safety, saves energy, and makes the whole system last longer. So what is our solutions? Our solutions is to redesign the steering system using three key elements. First, advanced rotational mechanics. Second, sensor-based control. Third, real-time software that adjusts steering feedback. This will help drivers to experience better control, especially during sharp turns or at high speeds. It also reduces driver fatigue, lowers accident risk, and extends the lifespans of steering components. In short, we are moving from basic mechanical systems to a smarter, safer, and more responsive driving experience. Do we have any technical issues to solve? The answer is yes. There are a few key challenges. First, sensor accuracy and response time. The systems must react instantly to varying speeds and steering inputs. Second, software calibrations and its adaptive steering algorithms must be tuned accurately for different vehicles models and driving style. Steering also must feel right across different cars and drivers. Cost is another issue. Adaptive systems can be expensive, so we need to keep it affordable for compact and electric vehicles. And lastly, durability and maintenance. The system must stay reliable under real world conditions by ensuring long term reliability of moving parts and electronic components. We see these not as problems but as chances to innovate and create a better, safer future for driving. In conclusion, our solutions make steering smarter, safer, and easier. It helps drivers to stay in control, save energy, and improve safety. This is why innovations mechanics is so important. Things like variable gear ratio steering, electric power assisted systems, or even smart adaptive steering all aim to solve this exact need. In short, if we apply what we learn from physics, particularly rotational motions, we can design better, smarter systems that keep us safer on the road and make our driving experience smoother and even more energy efficient. That's all from us. Thank you for watching.